right, let's get started. Most people are here, so let's wait no longer and get started. So welcome to this Zabbix meetup hosted by us BNC. Who's going to talk? Me. I'm Tobias from BNC. I've been here for a little bit more than 7 years, mainly doing Zabbix implementation for different customers, as well as managing our internal Zabbix with my colleagues, which is responsible for monitoring all our managed service customers. I'm also joined by Edgar Smelvers from Zabbix themselves. He will talk to you a little bit later. So first, just a couple of words about us, so BNC, who we are, what we do, just very, very basic. So we were founded in 1998. We have currently 3 locations in Switzerland. So as you can see, one in Zurich region, Dübendorf, in New Bern, in Gothen and Schönbühl, and in Yverdon in the Swiss Romand. We are a little bit over 100 employees with about 50 million Swiss francs in revenue. And we offer services mostly around network security and data. So that's basically already it. Of course, we're also a Zabbix certified partner, which is probably the most important part for today. So let's talk about the agenda. What are we going to talk about today? First, I'm going to show you a little overview of Zabbix. What does it do? How does it work? What can it do? Then Edgar is going to show you what's new in Zabbix 7.0. So the new features, the most important ones. And then at the end, we will have a little use case and demo. All right, so let's get started with the overview. So what's Zabbix? It's an open source, so this is quite important. It's fully open source monitoring solution, so you can have a look at the source code. You can use it, complete feature set for free if you want to, of course. There is support offerings. It's designed to monitor a lot of different metrics from all different systems all over the world. Lots of people are using it. You can see some examples here. Lots of installations worldwide. So what can you monitor with Zabbix? Basically, more or less everything. So on the right-hand side of the slides, you can see some examples of services that you can monitor. So services, applications, databases. So you can monitor access control things. So you can monitor, I don't know, door sensors, humidity sensors, IoT sensors. You can do some KPI monitoring. So you can monitor service monitoring. You can also do things like number of visitors to your website or some things like that. You can do, of course, capacity monitoring, so utilization of your infrastructure, so CPU usage, bandwidth, and use that to help you plan ahead, make your next budget decision. You can do configuration monitoring, so keep track of, I don't know, on your network devices, which switches have which OS version installed, for example. You can use it for inventory purpose, so you can read out information from devices, save it to the inventory, and then, for example, you have a list of all the serial numbers that your network devices have. And you can also do some security monitoring by checking for open ports and, I don't know, monitor past VD file changes on Linux and things like that. Let's talk a little bit about infrastructure or architecture, sorry. So Zabbix is comprised of 3 main parts. So you have a server, this backend server. It's responsible for all the data collection or most of the data collection. It's doing the analysis, so it will see if there needs to be some alerts generated. It can be deployed on basically almost any Unix flavor. A full list is available in the documentation. And it supports a high availability cluster natively from Zabbix. So you can have an active-passive cluster to have some redundancy here. For the database, this is basically the most important part because it's where all your data lives. So this is the data that you collect with the monitoring, as well as all the configuration. So like, what do you monitor? How do you monitor? This is all stored in the database. You have basically two choices here. You can either use MySQL and the forks they have, the community forks such as MariaDB, or you can use Postgres optionally with the Timescale DB extension to compress the data and use time series data, which is in our experience quite recommended because you can save a lot of disk space and get some performance benefits as well. For the front end, it's a PHP application. You use it to configure the monitoring, you use it to visualize the data that you have collected. Yeah, we'll see more about that in upcoming slides. Of course, distributed monitoring is also possible. So for that, the Zabbix has what's called a Zabbix proxy. So this is a piece of software that you deploy on a server, for example, in a remote site, in a different network security zone or similar. What it does is it does the monitoring within this zone and sends the collected data back to the main server. So this gives you some advantages that you will see on the next slides. But important here is, so you can have an unlimited number of proxies. So if you have a huge number of sites, for example, you can have as many proxies as you have sites. And it's also good for scaling because the proxy takes some of the load of the main server. So, and what's also good, so you can have active proxy, which means the proxy connects to the main server, or you can have it the other way around. So the server connects to the proxies, and you can mix and match those approaches to whatever best fits your security needs. So some of the advantages of using proxies is you can use a data compression. So that means that you will need, if you have bandwidth constraints between your sites, for example, you will need less bandwidth there. As already mentioned, you can monitor things that is behind a firewall, a DMC. You just need to open one connection into or out of the DMC or the security zone or your remote site. And all the monitoring itself happens within the same zone. So this is also quite nice. The Zabbix proxy can also buffer data. So if you have any network issues, monitoring will continue by the proxy. It will collect the data. Once connectivity is restored, it will send all the data back to the central server. So you will not miss anything. Proxy can also run some custom script that you can write and save on the server. So you can extend the functionality if you need to. And you can control them all from within the Zabbix proxy UI. Zabbix server UI, I mean, sorry. Let's talk a little bit about the Zabbix deployment. So basic deployment can be quite easy. So you can install it very easily in a couple of minutes. Yeah, just install a database, create a database, user, install the packages or containers or whatever you would like, and then you're up and running. There is a lot of templates out of the box. So templates is like a collection of monitoring targets and alerts and everything grouped into one. So you have templates for, let's say, operating systems, for network devices, for some applications, for cloud vendors, and all different stuff. So you can use them to monitor, get started quite quickly with the monitoring. You can also create your own. You can adapt the out-of-the-box templates to your own needs. So you're very flexible here. You can automatically discover and create hosts. We will see that later on in more detail. And as already mentioned a little bit, you can deploy Zabbix in different ways. So you can install from packages, you can run containers, you can use cloud images if you're in the cloud, or of course you can compile from source if you want or need to. And you can send alerts from Zabbix to different endpoints, which we'll also see in future slides. So what's also quite important is that you are in control of your data as you're hosting it yourself, and you control the database. So all the data that Zabbix collect is staying in the database. It doesn't get any telemetry or any data sent anywhere else. And then, yeah, you have different concepts within the database. You have a history, which is all the data that gets collected by Zabbix. So if you have a frequent polling of your metrics, this will create quite a lot of data. That's why we also have the concept of trends. So trends is creating one value per hour, and it will create the minimum, maximum, average, and the number of values collected within the last hour. And it will save that to the trends tables. So that means you can keep history for a shorter period, let's say, for example, a month, and then you can keep trends for a year or more, and you can very flexibly define how long do you want to keep these values each. So this allows you to keep trend data for quite a long time while not having too much data in your database to keep it contained in size. So how do we get the data into the database, or what are the possibility of collecting data? And so here we have a few possibilities. Of course, we can use go agentless, and then we have very easy ways to get the data, such as ping. We can do TCP or UDP port checks. We can do SNMP checks using SNMP GET. We can also receive SNMP traps. We can do HTTP checks to see very basically, is the website there or is it not there. We can use IPMI for out of band or ILO monitoring. We can run SSH and telnet checks and execute commands on some systems if we'd like to. For database monitoring, we can connect using ODBC and execute some commands on a database to monitor its health. Zabbix has a Java gateway, which we can use to connect to Java applications, monitoring their health. You can connect to APIs and HTTP endpoints to get some data from them and monitor them. You can also write your own metrics and scripts. So there is different ways to do that and different places to put the scripts. So you can be very flexible here as well. Yeah. Then VMware monitoring is very easy. You just connect to, for example, vSphere using the API that VMware provides, and all your data stores, all your hypervisors and VMs are being added to Zabbix automatically. And you can do some web monitoring, so you can do web scenarios to test some multi-step scenario, navigate to a website, and then do some actions. Try to log in, for example, and see if everything works, and if not, which step is failing, and then alert based on that. You can also do some synthetic monitoring using some JavaScript. Of course, you can also use the agent, so Zabbix has an agent that you can install. It works on Windows devices and all the Unix or like platforms. It can, out of the box, monitor basic OS performance and also disk usage, things like that. So very simple. It can work in active and passive mode. So you can either connect actively from the agent to the server, or you can do it the other way around. You can also mix and match both approaches. You can do log monitoring. And also here, you can extend in multiple ways the functionality of the agent if you would like to do something that's not in the default feature set. So you can extend the functionality very easily. So once we've collected some values from the system, maybe we're not quite happy with what's coming from the system, and we would like to process the data before we save it into the database. This might be, for example, in the first case, we get back 12 Celsius, and maybe we want just to save 12 into the database, because then we have an int value, not a string, which is it takes up less space in the database, as well as we can, of course, create graphs for these kinds of values, which we could not do if we were saving a string value. So there is lots of different ways to pre-processing data before saving. So these are steps that are taken after the data is collected and before it's saved to the database. So we can use JSON paths, for example. We can use regular expressions to cut out some information using capture groups, for example. We can write our own JavaScript pre-processing. So in this case, we are changing Fahrenheit into Celsius. Or we can also use throttling, which is quite a handy feature. So let's say you really want to get quickly notified if a status of something changes. So you configure quite a low interval of polling the data point, which of course means you will get a lot of data back and you will have a lot of data in your database. So what you can do with throttling is you can say, okay, I'm going to poll it very often, but only save the value into the database if it actually changes. So that means you can save a lot of space as well in the database. Of course, we can work with Prometheus pattern and extract the data from there. There's also more options than the ones displayed here. This is just an excerpt. All right. So after we have gathered the data, of course, we want to create some alerts because the goal of monitoring is not just to collect the data, but actually to evaluate it and create some alerts if things are not as they should be. So here we are working in Zabbix with triggers, which define some thresholds. When do we want to create alert? So as you can see in the screenshot behind in the back, we have different severities that we can use. So we can define how bad is this alert, and then if the trigger fires, then we will get an event or a problem, which we can see here, and they also then reflect the severity. Yeah, we can do some root cause analysis using tags, for example. We can do some anomaly detection using some mathematical functions. We can use baseline monitoring similarly, or we can use a trend analysis, which we'll see in the next slides as well. So let's go there. So maybe we want to react proactively and not just report the problems when it's already there. So what you can do is we have some forecast functions, for example, within Zabbix that you can use. So based on the data that's already been collected, and we can say, okay, how much, for example, how much free space will there be on the server in a week's time? So that we can say, oh, that's not enough, and I want to react now rather than only in a week. Same we can also do, for example, when will the server reach less than a gig of free space? And we can alert if this value goes, for example, under 1 week. So I already know, okay, it's going to run full in a week based on the data from, let's say, the last 12 hours or something. So I can react before the server runs full, or before we hit even like a fixed threshold of, let's say, 80 or 90% or something like that. Of course, once you create an alert in the dashboard, that is nice and good, but you probably want to have some actions to alert some people, or create a ticket. So there we also have multiple possibilities. So we can send email, SMS, and we can use webhooks. We'll see that on the next slide a little bit more in details, but with the webhooks, we can talk to APIs and of other systems. We can try to auto-remediate issues. So for example, if a service goes down, we can try to restart the service using a script or some remote commands executed by the agent, for example. We can try to escalate the problem. So let's say if it hasn't been acknowledged within a certain time period, for example, we can say, okay, now I want to send a message to the boss instead of just to the user. We can have different messages based on the role of who gets the message. So basically, maybe to technicians, you want to send a different message than to a manager. That's not in a technical role. We can do that. And we can enhance messages with information from the event and from the hosts that are involved. So we can, for example, send information that's in the inventory, such as the serial number, and we can add the data from the event into the message dynamically to enrich it. As previously mentioned, using webhooks, we can connect to different systems. So, for example, ITSM systems and different messengers. Zabbix calls it a webhook. It's just JavaScript, so you can. There's many out of the box, such as the ones you see on the bottom, as well as more. And you can modify these webhooks to extend functionality. You can create your own webhooks. If you're missing some feature, for example, it's all quite easy to do. Of course, if you have a big environment, you do not want to add all your hosts manually into Zabbix, because this would be a lot of work, a lot of pain, a lot of copy pasting probably. So why not let Zabbix do it for you? Here you also have a few possibilities. One of them is network discovery. So what you can do is you can scan the network. You can define what subnets do you want to scan with which ports, for example, or what checks do you want to do. And then depending on the result of the scan, you can do actions such as create a host in Zabbix, add it to a host group, assign the correct template for monitoring, maybe execute the script or notify somebody that you have added this into the monitoring automatically. If you're using the agent, you can also use auto registration, which means if you install the agent on a server, it can automatically connect to the Zabbix server and say, hey, I'm here, I want to be monitored. And you can send some additional metadata to Zabbix, based on which you can then define some actions to assign already, as you can see here, assign the correct templates, maybe notify the database admin, because you see, oh, it's a MySQL server, so I don't want to notify the Linux guy, but the DB guy. And you can also, of course, here execute some onboarding script on the hosts if you want to. A different kind of discovery is low-level discovery. This is used on the host itself, and it's used to create, update, and remove entities on a host that might change or are not always the same. So the example here is file systems on Linux, of course. This also works the same for Windows, or it's also the same for network interfaces, for example, on a switch. So Zabbix automatically detects here all the file systems that are on the host. It will create items, triggers, and everything for all the file systems it finds. And then if the file system is removed at some point on the monitoring target, it's also removed in Zabbix and added back if it appears again or if a different one comes. So there is no need to do that all manually. Of course, we also want to be able to visualize all the data that we have collected. And for that, we also have different tools available to us, which we'll see on the next slides. So we can build dashboards. Many different dashboards, for example, for different teams, for different users, for different applications, whatever you want. A dashboard contains of different widgets that we can combine. So here you can see it's like a geographical map. You can see some single values. You can see a list of problems. You can see some graphs. So yeah, this is just an example. There's also more widgets than the one listed here. So as I said, one of them is geographical maps. If you add the coordinates to your host, then they can automatically be displayed and grouped on a map. So if you zoom in, the points will spread out if they're not exactly at the same location, and they will group back together if they're close to each other when you zoom out and you see on one glance, okay, maybe I have an issue in this location here. Oops, sorry. And here you can see Italy, for example, is all good. This just helps you very quickly get an overview of your system. Another type of maps is network maps. So you can create network maps where you can display systems, you can add links between systems, you can add real-time data. So you can see here, for example, you can see power usage in the data center. For example, this is real-time data or humidity or things like that. You can change colors of links, for example, depending on some issues in Zabbix. You can have nested maps. There's lots of options here as well. You can create reports. So if you want to do weekly or monthly or whatever reports, you can define dashboards, define when to send the report based on which data. So you can say send it weekly with the data from the last week to these recipients. And then you can automatically, Zabbix will create a report and send it to these people on a weekly basis. We can also do business service monitoring. So here the example is quite simple. We have an online store. It contains 4 child services. So we have the website, we have 2 databases, and we have a service provider for the payment. We can see we have an SLA. We don't see what the target SLA is. We just see here that it's green, and we are 99.4%. But we see, okay, the status currently it's not okay. This is because the website is down. So we have 1 child services that's not okay, and this will cause the parent service, in this case, our online store, to be in an error state. So we can also use this to send alerts and to get an overview of our services and not just our servers. Of course, security is also an important topic. So what can we do here? So main point is the communication between all the Zabbix components. So between the server and the web interface, between the server and the database, server and the proxies, agent and the server or proxies, and all the command line utilities. This can all be encrypted. You can either use pre-shared keys or certificates. And yeah, for the users themselves, there is a quite granular user and permission concept using user roles and user groups, where you can limit users to only be able to do the actions and see the hosts that they need to see to do their jobs. So you can easily segregate users like that. Also, we have an integration with HashiCorp or CyberArk Vault. So the monitoring, it often, of course, uses some credentials to connect to systems which it needs to monitor. So let's say an API token, for example, for an API that we want to connect to. And we prefer to not store this data in the Zabbix database because, yeah, we don't want it. So what we can do is we can connect to one of these vaults, and then Zabbix will just read out the credentials from there, and only save it in memory, and use it to connect to the front end. And we will not be able to see it within Zabbix as a user. We will just see that it's connecting to the vault to get the secret from there. Of course, it also has the advantage that if we change credentials, we just need to change the credentials here, and we don't need to actually touch Zabbix, as it will fetch the credentials from the vault again. Yeah, of course, as already mentioned, it's open source, so you can have a look at the source code for yourself and do an audit or check for vulnerabilities if you'd like to. Zabbix also has an API. Yeah, you can use that to basically monitor or do almost anything that you can do in the front end. So whatever you want to do, you can create hosts, update hosts, delete hosts, tick dashboards, even maps, basically whatever. It's also very well documented, so you can use this classic use case, for example, is write your own application that connects to your CMDB and then create the host from there. So you don't need to manually add them in the CMDB as well as in the monitoring. Yeah, of course, we and Zabbix themselves offer professional services around Zabbix. So there is support services from us. There is also support services from Zabbix themselves. You can get training. You can get help for your deployment, or if you're trying to migrate from an old version to the new one, or just basically anything else that's Zabbix related, just ask. Yeah, if you'd like to get started, as I mentioned previously, it's quite easy. Zabbix.com/download. It looks like this, except of course the new versions than the screenshot here. But yeah, you can download from packages, or if you would just like to play around, you can also just download an appliance, let it run in your local virtualization system, and have a go yourself. All right, that's it from my side for now. And I'd like to give the word to Edgar from Zabbix, and he will talk to you about the new features that have come with Zabbix 7.0.
Hi, let me share my screen. Okay, I hope it's visible. Okay, so I'll start with introducing myself. So my name is Edgar Smelvaris. I work for company Zabbix as technical support engineer for about 6 years now. And my main work is related to, well, everything that we do for our customers, providing support, providing trainings, consultancies, and everything else. Okay, and yeah, here I will talk about what's new in version 7. I believe most of it will be more useful to people who already know Zabbix, but anyway. So, okay. Yeah, we've been trying to focus on, well, enterprise-grade features that allows you to use it in your company, in your corporation, allows you to cover more use cases of what and how you might want to monitor, better performance for large-scale installations, and yeah. Okay, so one of the first features we want to talk about is synthetic end-user web monitoring. And what we mean by this, so it's been possible in Zabbix for a long time already to monitor web pages in somewhat simplistic ways. You could just load a web page, load the contents and check something in it, or you could also follow web scenarios where you can try to follow multiple steps and see if something works the way it's supposed to after a login. But something that wasn't covered up until now is full end user experience of your web page, plus also possibility to save screenshots. And this is what we have introduced now. Basically, it works in a similar way as Selenium web testing. Okay, under the hood, we do have a real browser running there, and then we write a script that tells the browser what to do, what should it try to open, and what should it try to click on, and so on. Okay, so you can use Selenium Server or just a web driver with the browser that of your choice. So things like Chrome, Edge, Safari, Firefox. That web driver or Selenium could utilize it in a headless manner or not. That's details depend on the configuration of it. We don't provide it as a package from ourselves, so that's a third-party product, but it can easily be installed. And one of the simplest ways is just to use a container to deploy Selenium. And then on Zabbix side, what you need to do is define in its configuration where is this web driver located, how to communicate with it. And after that, all you need to do is create a new item in Zabbix of type browser. Okay, and in reality, that browser item, it executes JavaScript. Okay, so you type in the JavaScript yourself. There's a very simple option example here. So it just tries to open some page and does something and gets back the result. Okay, much more complex scenarios are possible, but to really do create them, you do need to know JavaScript a bit, or you need help from somebody who knows JavaScript. Okay, now out of the box, you can already use this very simplistic approach and you will get some statistics about your page. You can save a screenshot about your page, and there's even triggers for when it's loading slowly and when it's not available. Okay, but anyway, the main goal of this template is to show an example, and then you can, well, fine-tune it, change it according to whatever you need to monitor on your sites. Okay, then, well, as information it returns, it's actually encoded in JSON, so you can use dependent items in Zabbix to extract each individual detail. And one of such details can be a screenshot. So it's loaded as base 64 encoded, well, text, and then we can save it in a new type of information in Zabbix called binary, so that we can save this binary data, base 64 encoded picture, and later on see exactly what did we get when we loaded that page. We can see here a thumbnail, and probably this means that the page was loaded fine, but maybe in other cases we might notice some error, and then you can click on it and see well, full-sized screenshot of that page. Okay, it also includes a host dashboard that shows you various other statistics about how the page was loaded. Okay, then important change in how we collect data and how we scale when collecting data. So one problem that Zabbix could have on large-scale installations is that we need to connect to a lot of addresses and ask them for metrics, at least if we use polling type of data collection. And we always had limitations of how many processes in parallel we can run and how many such communications can happen in parallel. Okay, it used to be most of data was collected, not all of it, but most was collected by a process called Polar. And there was a maximum of 1,000 such processes that you could start. Okay, and that kind of limited in how much data you could collect. There's always a workaround. You can add proxies. Proxy, you can start 1,000 more of such processes. And if that's enough, not enough, then start more proxies and add more proxies and so on. But this becomes pointless if you just need to start adding proxies to collect more data while everything else is able to handle that load. So the first thing we did was we distributed data collection into multiple sub-processes, or they are processes of their own. Okay, so now we have specific process for SNMP polling, for Zabbix passive agent polling, and for HTTP checks. And most importantly, most importantly, they now work asynchronously. Okay, so it used to be that if you had this 1,000 pollers running, each one of them was working synchronously, and that means if it has initiated a connection somewhere and expected back a result, it had to wait for that result until it could do the next thing. Currently, on most installations, one such poller per type will be already enough because they can do up to 1,000 such connections in parallel. Okay, and that means we can already collect much more values, and it also means that you can start more of these processes to collect even more. Okay, the maximum amount of concurrent checks is configurable, but defaults to 1,000. Okay, and here's a comparison of the old method and the new method of how they work. So old method, we ask for a metric, wait for response, ask for the next one, wait for response, and so on and so on. If those responses come in very fast, then it works nice. But if for some reason some devices answer slowly, then it just waits until timeout is reached. Okay, and default timeout used to be 4 seconds, so it could wait up to 4 seconds. Now what we do is we send lots of requests in parallel, and then we wait for them whenever they will come in, they will. but as soon as, well, let's say it's up to 1,000 requests sent. As soon as some come back, we are ready to send out more requests. Okay, and a comparison of how utilized the collector processes are. Here we have Zabbix version 6.0 and pollers somewhat utilized, not too much. This still works absolutely fine, but still we do see they are utilized up around 40%. And then when moved to version 7.0 upgraded, so different processes are now being utilized. We see that here we have a sharp decrease, and this is just one agent poller utilized to, well, 10%. We even had to limit the max concurrent checks to make this. Okay, then also very important for many enterprise levels, so high availability and load balancing for the proxy services. So a problem that existed was that if you do monitoring by proxies, as Tobias just explained what they were for, so if that proxy suddenly, well, something happens to it, it's no longer the machine crashed, network is unreachable or whatever, the hosts monitored behind that proxy are just not monitored at that moment at all. So no data was being collected for them. And that is a problem. So we've introduced high availability and load balancing here. This works by introducing a new concept called proxy groups. So whenever you create or modify a host, you can still set it to be monitored by the server itself, by an individual static proxy. In that case, AJL load balancing will not be used, or now you can use a proxy group. Okay, and then this host could be monitored by any proxy in that group. And if one of those proxies disappear, Zabbix will move it automatically to another proxy and it will keep monitored. Okay, so proxy groups need to be pre-created. There's very little details you need to provide for them. So there should be a unique name. There should be a failover period. So how quickly after a proxy disappears, should we start failing over to other proxies? And minimum number, jumped ahead, minimum number of proxies. So if you know that the load, the amount of hosts you have, can be handled by 5 proxies, but not by 4. So if we reach 5 and lose another proxy, stop balancing the load, let those 4 remaining proxies do whatever they are doing at the moment, but stop moving other hosts to them, okay, so that you don't overload them. Okay, so failover period to decide how quickly should we move away from a proxy which seems to be offline. So minimum number I already explained. Older proxies are not entirely supported here. Okay, so while older proxies can deliver data to Zabbix, they should not be a part of proxy groups. Okay, and yeah, if you have less than the minimum amount of proxies, then proxy group is considered offline, but that only means that we stop load balancing. So which proxies are still online will continue to work. Okay, if you would upgrade to version 7, you would not start using proxy groups automatically. You need to set it up, so you need to pre-create a proxy group. And then for each proxy, which should be a part of the proxy group, you need to select that. So this is in proxy configuration. Okay, then about load balancing. Okay, so rebalancing in case if proxy fails, that's pretty clear. But how do we balance the load normally? So Zabbix has information of how many hosts are monitored by each proxy, and it will try to rebalance things if the difference is more than twice the amount of average or less than half the amount of average per proxy. And it also has to be more than 10 hosts. Okay, if average is 6 and you have 3 on one of them or 2 on one of them, it won't try to rebalance anything. The difference is not big enough. Okay, and then hosts exceeding the average will get hosts, proxies exceeding the average will get hosts unassigned from them. and assigned to other proxies which have the least amount of hosts monitored by them. And this is how it would happen. So this is a situation where we have average 30, and one proxy has 15, another one has 60, so it's unbalanced. And then we start moving hosts around so that all proxies have the same load. Another option when you might need to rebalance is when you add a new proxy. So you have existing proxies which have some amount of hosts, and then you add a new one. That one at that moment has 0 hosts. So Zabbix then recalculates what's the current average, is the total amount, is the difference more than 10, and then we'll start taking some hosts and assigning it to this new proxy. Okay, there's also a question, how do Zabbix agent communicate with proxy in AJ mode? Because you have no control over which exact proxy will monitor this host. So, and not only the agent, your whole environment must allow all connections from all of these proxy nodes and must treat them equally. Okay, and that means also in some SNMP or firewall configurations, you should have all the IP addresses, and in Zabbix agent configuration, also all the IP addresses should be configured so that they can communicate with all of these proxies. Okay, then another improvement in proxy performance, proxy memory buffer. Okay, there are now 3 different memory buffers. So disk, which is actually the same as the only option in previous versions, and memory and hybrid. And this is a configurable parameter in proxy configuration. Okay, so how it worked up to now and still works with the disk mode. So the proxy collects a value, no matter how it collected it or it was sent to it, doesn't matter. Then it will pre-process it, and then it will save it into the local database. So it will always do these writes into the database. Okay, and then another process will read it from the database and send it to Zabbix server. And sometime later, one more process will have to execute delete queries in the database to remove it from that database after a while. Okay, this could be a significant performance bottleneck on larger proxies, and maybe also in case if you have some embedded very small proxies. Okay, so now we have the memory mode where proxy collects the value, just like it did in previous mode. It pre-processes it, again, nothing changes so far, and then instead of writing on disk in the database, it sends it directly to Zabbix server. If at that moment it cannot send it, there is a buffer in memory where it can keep those values for some time. But if at that moment you restart the proxy or it runs out of that memory buffer, those values would be lost. Okay, so this is something you have to be prepared if you use this mode. Then probably the best option is to use hybrid mode. So this will work like the memory mode. So we try to avoid writing to database at all times, try to send things directly to the big server. But if there's some problem with sending data to the server, so either connection to it fails for some reason, or it's just slow and the buffer is full, then we still do write it on the database to avoid data loss. Okay, but only in cases if there's something wrong with the big server. Okay, next, something that people have been waiting for a long time. Centralized control and pretty high increase in the maximum timeout and lots of customizations for specific needs and timeouts. So it used to be that you could set timeout only per server or per proxy in its configuration file, and it was global. It applied to almost all item types, almost all polling data collection, with some exceptions like HTTP agent and script. And even then, this timeout could be set to a maximum of 30 seconds and no more. One of the reasons was the second topic we discussed about synchronous data collection. If this timeout is increased to some very large value and some hosts are not responding and timeouting, then the process would wait for a very long time and it might be missing data collection for other healthy hosts. Okay, now that we have this asynchronous data collection, we can afford much different timeouts. Okay, so in version 7, we now have per item type timeout, and it is configured globally in Zabbix frontend. Okay, and then you can add overrides also per proxy and up to each item individually. So if I know this is some kind of slow item, it's connecting to some API on some slow remote host and takes a while to execute and return back data, then I can set it even up to 10 minutes. Okay, so main configuration, global configuration is done under administration general timeout section. Okay, and each item type can have its own global timeout. Then on individual proxy configurations, I can override that. So I can keep the global or add local override. So on this proxy, Zabbix agent checks would then be, well, with a 10-second timeout or whatever. Okay, and then for each individual item on a template or individually on a host, I can also add, so this item is very slow. I'm going to add an override, and this is going to be collected, well, timed out after 45 seconds. Okay, now the configuration parameter in config file still exists, but is now used only for communication timeout. Or, well, specifically in case of Zabbix agent, if you use an older version of the agent, then we still use this old timeout because older versions of the agent does not know about these increased timeouts, and we could run into additional problems then. Okay, then during the first demonstration, we also mentioned network discovery. This has also been improved with asynchronous network discovery. Okay, so how it used to work was that there was just one process executing the whole discovery. So if we have like up to 250 something hosts here and 3 different checks and timeout 3 seconds, we go one by one. So first host, do SSH, do HTTP, do SNMP. And if they respond quickly, it goes through this quickly. But if some of them are not responding, which is very often happens in case if you use network discovery, lots of addresses won't even respond at all because there is nothing there. Okay, then again, the whole process waits for the timeout here and only then continues. Next one that does not exist waits for the whole timeout and only then continues. And that means that scanning large network segments could take a very long time. Okay, and well, it also depends largely on the timeout settings. If it's set to 3 seconds, that's one thing. If it's set to 30, for example, well, it takes even longer. Okay, so now in version 7, the discovery process has become asynchronous and is threaded. And just like for the data collectors, one process could do up to 1,000 connections in parallel. Okay, and then some of them respond, some might not, but anyway, things are happening very quickly now. Now, in the discovery rule itself, there is an option to limit. So if you select one concurrent check, this works just the same way as it did previously. Unlimited actually means 1,000, and then it could be custom. Why you might need custom? Because in some cases you might run into some security scanner issues like DDoS prevention and or intrusion detection prevention systems could consider this to be some kind of an attack or network scan or something. Okay, and the way it works now is that, yeah, we will send out all of this basically in parallel. We get responses from some of them, and then later on we decide that other ones reached timeout. Okay, and yeah, there's internal processes monitoring performance of all of these data collectors and discoverers. Then, something that also has been requested by Zabbix users, ability to use history push method to push metrics into Zabbix from most probably some third-party products that have some metrics themselves, and you don't want to pull them from that device, you just want to push them into Zabbix. Okay, so an API method history push has been introduced. And yeah, you can push it into Trapper and HTTP agent type with trapping on. Okay, then you can limit source IP address of who is allowed to push data here, and you need a user that is allowed to execute this in API. And then simple API request looking like this can be sent to send in values. Okay. Next, there has always existed an option to execute scripts from the front end. So the super administrator kind of prepares such scripts, and then a user, when he sees that there's a problem happening, he can click on the problem or on the host and execute some script. Those scripts could be doing something very simple, like it appears that a host might be down. You could click on it and run ping and immediately see the result output of the ping. Or they could be executed on the agent itself or via SSH agent, for example, run commands like systemctl restart something. Okay, but then as soon as you allow, well, some Zabbix front-end users to run such commands, which could be dangerous, you might want to limit of what they can do there. So it used to be that you had to prepare such commands for each individual option. Like if I want to restart Apache, I prepare one script that does systemctl restart HTTPD or Apache 2. Okay, but now you can provide manual user input here. And instead of just defining one script for each use case, you define a more universal script and then ask for user input. So which service do we want to stop or whatever else? But again, this becomes dangerous because they might start restarting some services that are not related to the problems. They should not be allowed to restart just any service. Okay, so we have an option to sanitize the input. One simpler is, instead of allowing them to just type in those options, we can provide them with a drop-down menu, and then he only has a choice of restarting these three services. Or if we provide a string, we can use a regular expression and only allow it if the input he has provided matches that regular expression. And this is what it would look like for a user if he tries to execute such a script. He would press on the problem, choose the name of the script, which is restart Windows service, and then he has a choice. These are the services that the user is allowed to restart. Okay, then some major improvements on how you can look at the data you are collecting. Okay, there are some new widgets in version 7. So honeycomb, gauge, pie chart, host item navigator, and top triggers. Okay, these can show different data, different colors based on thresholds they reach and so on, and can select data automatically. So you could select, I want to look at interface number 1 on all of these hosts, and you can get info in one widget from all of the hosts. Okay, but more importantly, we have created a new internal communication between these widgets. So the dashboard can become much more dynamic when you look at the data. So you could be clicking at something in one widget, and what data is displayed on other widgets will change based on what you've clicked on. So an example here, we move over and click on something, and the other widgets here change what they display. Okay, similarly with host selection and or individual item selection, all of this could be used. Okay, I'm running out of time, so I'll try to quickly finish. If you use internal authentication, so it's still possible to use external authentication tools like Active Directory, SAML, Octavan Login, and others, you might still use internal. And in that case, people have been requesting, we need multi-factor authentication here. So now we've introduced an option to use multi-factor authentication. Just register with either TOTP or proprietary Duo universal prompt. For TOTP, you can use Google Authenticator, Microsoft Authenticator, which you can install on your phone. And well, then you have that additional factor whenever logging in. Okay, other improvements. Okay, license has changed from GPL version 3 to AGPL. That's not maybe as important for most of you and doesn't really affect most of you. We can do automatic version checks and show you when a new version of Zabbix is out and that you have an option to update your version. And okay, there's lots of other smaller improvements here, like streaming data to external Kafka, for example. What else is important here? Remote command execution reactive checks, aggregations. Scheduled reports support multi-page PDF if you have a dashboard with multiple pages and so on. Plus, our integration team is working constantly on creating and improving existing integrations and or templates. Okay, these are the ones that we've released quite recently, but they are always working on more. One problem that exists here is that the more templates we have, the more time we need to spend on maintaining them, because things change and then we need to adapt how we communicate with whatever external tools we integrate here with. But yeah, we keep working and adding more. Okay, that's all from me. Do we do questions now, or do we do them later once we're done with all?
I think we'll take them later. So yeah, let's get back. Where was I? Sorry. So all right. Yeah, sorry, we are running a little bit late, so I think it will take maybe a little bit more than until lunch. So just so we are aware, I should have about 20 minutes for my next part. So let me share my screen again.
May I jump in, Tobias? Sorry, just as an information, as for all the participants, we will provide the recording of this session afterwards via email. So to those who needs to run right now, we will make sure that you can join all the content. So no worries.
All right, yeah, so yeah, quick demo from my part, or a little use case that we did recently with one of our customers about automating Zabbix deployment with Ansible and containers. So yeah, here's what we're going to talk about. So how did it start, or what was the design that we came up with, why we chose automation and how, and then probably a slide demo. Let's see if time will allow it. So how did it start? We had a customer that wanted to replace multiple existing monitoring tools, and they chose to use Zabbix for that. It's quite a large environment, so it's a couple of thousand of switches, servers, access points, IoT sensors, basically everything you can imagine. So therefore, monitoring is quite essential for them to keep everything up and running, which is why the requirements were, or some of the requirements were, a high redundancy. So failure of one component of the system should not lead to a failure of the monitoring. High performance was just implied because of the size of the environment, which would mean that we have a lot of data points coming in. We needed fast disaster recovery because the customer wanted to get up and running quite fast in case of any issues. And we would need to be able to move the VMs quite quickly. We'll talk about that also on the next slide as to why that was the case. So what did we come up with? So you're already aware from the last few presentations of the main Zabbix components. So for the database, we chose to go with PostgreSQL with timescale, just because of the disk space saving and performance benefit. We chose to do a 3-node cluster using etcd and Petroni for redundancy. And we chose to install the database components with RPM, so package-based and not in containers, because the database server would just be running the database, nothing else. So we wanted to remove some of the complexity there. For the server part, we chose a 2-node high availability setup using Zabbix native high availability, which is quite easy. This is container-based, so on the server nodes there is a couple of containers running, providing the server and some custom tooling that we did. For the front end, we have also 2 independent front-end servers. They are behind a load balancer that is just using non-sticky session to balance the requests between both servers. They are also in containers. And then this all is running, in this case, in the cloud, but it doesn't really matter. There's no difference because it's VM-based still. But most of the environment that needs to be monitored is on-prem, so we need proxies for that. So we are going to use the new proxy high availability setting that Edgar's talked about previously. So we created a new network zone, which contains all the proxies. They are all in one group. So we have 6 Zabbix proxies that are in one Zabbix proxy group using the load balancing feature. So from a schematic perspective, it looks like that on a basic level. So on top, we have a user. They are connecting to the front end using this load balancer, which distributes the request to both front-end servers. The front-end servers connect to the database using another load balancer, just so they always, so the front end can always connect to the active database cluster node. The databases back up to blob storage in the cloud. So we have backups there for disaster recovery. And the front-end servers, of course, also connect to the active application server. On the bottom, we have the on-prem environment. So here we have the proxy group containing all 6 proxies. They are doing the monitoring and sending the data back to the active server node here. And we also have a management VM, which we use to run Ansible to configure and deploy all the things in the cloud. And we also run, this is a managed server, managed service from us. So we are responsible to keep this up and running, which is why on all those components, we also have the Zabbix agent reporting back to a Zabbix proxy, which we have here, which then connects back to our central Zabbix instance in our data center to report on the health of all the components here. So we can get alerts and monitor how this is all running. So let's talk a little bit about automation. First of all, why did we choose to use automation? So there's many reasons. The most important for them were, as I mentioned, we need to move VMs. The reason for that is the customer currently doesn't have managed VMs in the cloud, but they will have them in the future. They're working on it. And once they are available, we will need to move to those VMs. So we will need to redeploy the whole environment. And this is just a way easier and simpler if we can use it, do it using automation. As previously mentioned, disaster recovery needs to be quick. So this is also way easier if you have already everything automated. So you can just let the playbooks do the work. Of course, using automation, everything is way more consistent. It's always the same. You have no configuration drift between either the different machines. So if you have 2 front-end servers, for example, and also between environments. What I did not yet mention there, we have a production environment. We have an integration environment that's the same as production. And we have a development environment as well, and the lab environment that you will see in a second in the demo. So using automation, we make sure that these stay consistent and everything is the same between all these environments. Also scalability. So if you need to add a third front-end server, for example, this is very easy. We just add it to the Ansible inventory, run the playbooks, and it's up and running. It also simplifies patching and upgrading. We can see who changed what because everything is in a central configuration. So, and everything is in Git, so we know who changed what and when. So what did you want to achieve? We wanted to achieve that if we have a completely empty VM where we only have an Ansible user with its public key for login, we can just run the playbooks and rebuild the whole environment more or less from scratch. We wanted to build container images automatically, so Zabbix provides official container images for all the components. We are modifying them slightly, adding some scripts from our own, for example. So this is why we need to rebuild the images, and we do that automatically using GitHub Actions. And we'll see a little bit more about that in the next slide. We want to be able to differentiate between the different environments, as already mentioned. And we want to use tags, so we can only redeploy or run the playbooks for certain things. So if you just want to I don't know, add a new front-end server, we can just run the web server task, for example. And we want to have secure access to credentials. So we are using Azure Key Vault for playbooks, as well as for Zabbix is also using Azure Key Vault to access credentials that it needs for the monitoring. So how does it work? As you saw previously, we have a database management server. This is where we run the playbooks. And then we have basically two main playbooks. One that's doing the basic VM configuration. So it will create users. It will install all the basics that are necessary. Basically, this is doing more or less the same on most VMs. And then we have an Ansible playbook that's doing the deployment of the Zabbix components, where you can use the tags to specify what exactly we want to do. It's two Git repositories. So we have one repository mostly for the containers. So here we have Docker files, we have the GitHub actions, and we have everything separated by the different environments. So if you modify some Docker file for int, it will rebuild the int files, the int images, and push them to the container registry. So the next time we run the playbook, we will use the new images. And then we have a different, a second repository, which contains the playbooks. And this is also doing application installation. So it's creating this database, installing all the daemons needed for it, installing Podman for the containers, creating the containers. We're also adding some scripts to the Zabbix frontend using the Zabbix API, so we can more easily develop them using using not just the environment provided by Zabbix, but actually using Visual Studio Code, for example. And of course, we can keep track of changes to the scripts because they are then in Git and not just managed in Zabbix frontend. So how does it look like? Let me quickly go here. So first of all, this is running our VMware environment in our lab, one of our labs. So as you can see, we have 3 database servers. We have 2 front-end servers. We have a load balancer. We have the management VM where we will be running the playbooks. And we have the 2 servers that are doing the monitoring. I need to move this Teams sharing thing around. Okay. So if you go to the front end, you will see we have a Zabbix HA cluster, active standby node, server lab 1, lab 2, same as we saw previously in VMware. And we see, for example, we are getting data here. This is front end node 1. We get the data from the agent. Everything's looking good. And we are using here in the lab, we are using HA proxy as a load balancer. So as you can see, both front-end nodes are up and running. And we have 1 active database nodes as we are querying the Patroni API for the active node, and only one will report as the master node at a time, which is why only 1 node is green here for the Postgres servers. So now what happens if we need to change something or redeploy something? So in this case, we will kill front-end server. So I have snapshots here. So maybe first of all, let's go to here. So you can see if I do let's look at the containers, I can see I have a front Zabbix agent as a container is up and running. I have Zabbix web service that's up and running, just providing the front end. I have Zabbix agent that is running, not in the containerized environments, for to monitor the OS. Yeah. So now I will revert to the screen snapshot. And now let's reconnect. Okay. No. Okay. Yeah. So you can see Podman doesn't exist. Zabbix agent doesn't exist, so the VM is basically back to basic. So now we can let the playbooks run. So we have the first playbook. This is, so you can see I'm running the playbook. It's called deploy machines. I'm running in the lab environment, lab inventory. And let's do it. So you can see it's skipping some stuff because you're in the lab. But then it's preparing the users for the Ansible. So it's creating all the users. So we have different users that need to manage the environment. It's creating these users on the server that I reset. Now it's adding the SSH keys for the users. It's adding them to the sudoers group so they can elevate their permissions. And then we'll see in a second, once it's created all the users. Should be the last one, I think. Exactly, now we are installing Podman, and we can see here, so here we can see all the servers that we have, right? But as I mentioned previously, the database is not containerized, so we are not installing Podman there. So you can see we have only Podman on 4 servers. Now we need to wait for it to install on frontend server 2. This will take a second now, unfortunately. So we cannot speed this up. It will probably take about a minute. And then we should see that we have Podman again, and then we will see it will try to install, or it will install the Zabbix agent. And we can also see, if we go back to the front end here, we can see now we have no more data coming in for this host. So if we look CPU usage, we see last value is collected 3.5 minutes ago, which was before we reset the machine. And we will see in a 1 or 2 minutes, once the playbook is continuing and installing the agent, that we will see. Okay, now we can see we have installed Podman. We can also now see on the agent that Podman command is now once again recognized. We have no, however, we have no images running yet, or no containers running yet, I should say. Okay, you can see we downloaded the RPMs for Zabbix agent. Now we're installing the Zabbix agent. And then we should see some data coming back again in the front end once this has been finished. Creating the pre-shared key so we can have secure communication, and we're starting the agent, and we are also opening the firewall port so we can connect with the passive agent to the server. Okay, so we can see playbook has finished successfully. Now let's run the second one. So here we want to also use the lab environment. We want to say deploy Zabbix, not deploy machines, and we want to install the Zabbix pod and we want to install the Zabbix web service for the front end, and we want to install the agent2 podman. So this is the agent2 container running inside the same pod. Let's start that. In the meantime, while it's starting up, we can see here, once again, we are receiving data from the agent that has just been installed in the playbook. So we can also check here. So we can see we had this interruption here where we reset the VM, and until the playbook installed everything again. We can also see on our load balancer, if I refresh, that front end 1 is down, of course, because we reset the VM and we have not yet installed the front end again. So let's check back on what our playbook is doing. So we can see we installed some repositories, did some cleanup, and now we are pulling the agent images from the container registry. Unfortunately, in the lab, this takes quite some time, so this will probably take like 2 minutes. So in the meantime, I think if there is any questions, we can use this time to answer them. Questions doesn't need to be about the demo. It can also be about anything else Zabbix related from the previous presentation or just a general question.
Hi, I have one question regarding the proxy group, if I may.
Yeah, sure, go ahead.
Your colleague told us that there are 3 ways of implementation. Basically, one is the proxy, the second one is the server, and the third one is brand new, it's the proxy groups. And the question is whether we can utilize server as a backup if the proxy is not responding, is unreachable.
No, that's not possible. At least not with the native options.
Okay, thank you.
Yeah, exactly. So you can, yeah, sorry, go ahead, Dekars.
Yes, there should be, for high availability, there should be at least 2 proxies in a group. It doesn't work in any other way.
Exactly. If you in the front end of Zabbix, you have a host, you assign it either to be monitored by the server directly, and then it's high available if you have a high available server, you know it, right? If you assign it to a single proxy, then of course, if this proxy goes down, you will lose the monitoring. And then you have the third option, which is if you assign it to a proxy group with more than one proxy, then you will have redundancy in case of the proxy dying.
Okay, thank you so much.
Welcome. Okay, so now we see the images has been pulled. We have recreated the container. And if we check back on the front-end server, we should now see that our agent2 container is back up and running. And now this will also take some more time. Now we're pulling the image for the web container. So this is the front end itself. And once this is done and deployed, we should see on our load balancer that the second front end is up and running again. Of course, I could also have deleted both front ends. I could have also deleted the servers themselves. Yeah, but unfortunately, we didn't have time here for that as we're already over time. But yeah, as we're already waiting, if we have some more questions.
Tobias, I think there is a question in the Q&A.
Okay, let me check the Q&A. I haven't looked at that. Give me a second. It's loading the Q&A.
Well, the question is whether the history push can be used to collect the syslog formatted messages via UDP.
Not sure.
Theoretically, yes, if some additional integration is used. So Zabbix itself won't do that. Some other tool would collect syslogs then, and then push it to Zabbix. In that respect, yes.
Yes, exactly. So you can use, you can collect or send any data to Zabbix using history.push. So for example, what we are currently doing, or we are just in a POC phase basically, but one of the limitations of the Zabbix HA proxies is that you cannot use SNP traps anymore with HA proxies, because of course, you need to specify where to send the trap, and this might be a different proxy than has actually been decided to monitor the host by Zabbix itself. So it will not work. So we are now building a little application that we run on all the proxies that is taking the SNMP traps and then forwarding them to the front end using API and history.push. So something similar you could do, for example, in your example with syslog. Yeah. Okay, perfect timing. Now we see web container has been created. If you check back here, you can see it's up for 6 seconds. And if we go back to the load balancer, we should be seeing in a few seconds. Okay, it just came back online. So now it's very easy. So we can just redeploy the front end like that. Same goes for the server, same goes for the database. Database is a little bit more complicated. If you need to restore, of course, from a backup, then you need to manually insert the backup, but this is just one more step. It's also fairly straightforward. So yeah, there's a lot of things that you can do using automation if you have the requirements for it. Of course, we can also do very simple setups if there is no need for complexity or redundancy or anything like that. Yeah, that was it from my part as well. So I don't know if there is still any questions. If not, then thanks everybody for joining, and yeah, just feel free to reach out via email or any other way if you do have some follow-up questions. And thanks for joining.
Great job, Tobias. Thank you. Bye.
Thank you.
Bye-bye.
Yes.
Bye.
Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.